Okay, so we want to write a squared multiplied by b raised -1 multiplied by c raised -5 in terms of positive exponents. So this simply means a squared b raised -1 c raised -5 divided by 1, because there is a 1 in every number in the denominator. So those two have negative exponents, so I have to bring that down and bring that down. So a squared, when b raised -1 moves from the numerator to the denominator, it becomes b raised +1. C raised -5, when it moves from the numerator to the denominator, it becomes c raised +5. So the answer is a squared divided by b times c raised 5. So the second problem, 3a raised -4 divided by b raised 7, entire thing raised to the power of 3, can be done in a couple of ways. And I'll do both approaches and you can pick which one you like. So the first approach is to distribute the power. What do we mean by that? So I have a 3, and the entire term inside is raised to the power of 3. So that power gets applied to each term. 3 raised 3, a raised -4 raised 3, divided by b raised 7 raised 3. So that would mean 3 to the power of 3 is 3 times 3 times 3, which is 27. And you have a raised -12. That is a rule. If you have an exponent inside the paren and raise it to the power, you multiply the powers. So -4 times 3 is -12, divided by b raised 7 times 3, which is 21. So that is distributing the power, and we can move the exponent to the denominator because it has a negative. When it moves to the denominator, we have b raised 21, a raised 12. So that is the first approach. The second approach is to convert or cancel terms to positive exponents. So you convert to positive exponents or cancel the terms to simplify, then distribute the power. I personally like this approach because it's always better to simplify an expression prior to applying a secondary operation or a third operation. So if at all possible, we need to simplify whatever terms that we have on the inside, or inside of the parentheses. So I'm going to rewrite it as 3, b raised 7, a raised -4. I have to change it to a positive exponent, so I move it to the denominator, a raised +4. The entire term gets raised to the power of 3. Since there are only products, no sums, products and quotients only, so I can apply that power to each of the terms inside the parentheses. So I have 3 raised to the power of 3 divided by b raised 7 raised to the power of 3, a raised 4 raised to the power of 3, which would give us 27 divided by b raised 21, a raised 12. So we got the same answer. Again, it is a matter of choice as to which way to use. You know, some people are right-handed, some are left-handed, and that's just how it goes. So it's best to take care of the term that is inside prior to applying the exponent. So in the problem, I'm going to try and simplify the terms inside the parentheses. So 6, x raised negative 6, y raised 7, z raised to the power of 0 is simply 1. If I move x raised negative 6 to the denominator, it would become x raised positive 6. Raised negative 2. Now I'll apply negative 2 to each of the terms. 6 raised negative 2, y raised 7 raised negative 2, divided by x raised 6 raised negative 2. Some of you could use a calculator and, you know, guess the answer has to be 36, but I'm going to do it the exponent way. So 6 raised negative 2, y raised negative 14, divided by x raised negative 12. So I'm going to move, I have to move the x raised negative 12 to the numerator, and I have to move that entire term to the denominator to get positive exponents. So I would have x raised positive 12 divided by 6 raised 2 multiplied by y raised 14. So x raised 12, 6 squared is 36, y raised 14. And that would be the answer. So here is another example where we want to simplify each expression and write it in positive exponents. Again, I like to take care of the terms inside prior to applying the exponent. So all of the terms have negative exponents. So we've got to move the terms in the numerator to the denominator, denominator to the numerator. So if c raised negative 11 moves to the numerator, it becomes c raised positive 11. If a raised 2 moves to the denominator, it becomes, sorry, if a raised negative 2 moves to the denominator, it becomes a raised positive 2. If b raised negative 5 moves to the denominator, it becomes b raised positive 5. And I apply negative 6. And that would give me c raised negative 66 divided by, well, I don't want to skip a step. So negative 11 times negative 6 is 66. 2 times negative 6 is negative 12. 5 times negative 6 is negative 30. So the numerator has positive powers, but the denominator has negative 1. So we just have to move that to the numerator. A raised negative 12, when it moves to the numerator, it becomes a raised positive 12. B raised negative 30, when it moves to the numerator, it becomes b raised 30. So there are multiple ways to do this, but this is one of many ways. So there isn't much to simplify in this problem because I don't have any terms in the denominator, except for the fact I have a negative here. That negative simply means -1. So what we have is -1 multiplied by 4 raised -6 multiplied by y raised -6, and the entire term is raised to the power of -4. And since the terms are in product, we just apply the exponent, -1 raised -4, 4 raised -6 raised -4, y raised -6 raised -4. Four, multiply the powers, we have raised 24, and y raised 24. Not divided yet. The only thing that has a negative exponent is that term, so I can move that to the denominator. And I'll put a remark here. If I have a negative number and I raise it to a power, it all depends on the power that I raise -1 to. If a is even, then -1 raised to the power of that even number would be 1. If a is odd, the answer would be -1. So in our case, 4 is even, so we will simply end up getting 1 in the denominator. So 4 raised 24, y raised 24, divided by 1. Now, we don't want to pick up the calculator and evaluate 4 raised 24. Some calculators would actually break if you did that, especially the tiny ones that you get from Dollar General. It wouldn't even give you an answer. It will probably catch on fire. So we just have to write it in a simpler form. These two bases are different, but they do have identical powers. So I can write it as 4y raised 24. And I can do this because the two terms are in product. They have different bases, but they have identical powers. They don't have to necessarily be different. The key part here is the terms having identical powers. If you have identical powers, then we can bump the terms together as long as they are in product or quotient. So here we have -5, y raised 0, x squared, a cubed, the entire term raised to the power of -3. So let's get rid of that y raised 0. It's just 1. So -5 times 1 is simply -5. And then I have x squared and a cubed. Raise it to the power of -3. We have -5, which I could write it as -1 times 5, x squared, a raised 3. Now, once you get good amount of practice, it will come naturally, and you don't have to write the way I'm writing it. I'm doing this so that you can understand the process, but with practice, you know, you don't have to do all this work, you just know. So -1 raised -3, 5 raised negative 3, x squared raised negative 3, a raised 3 raised negative 3. We mentioned that negative 1 raised to an odd power is going to be negative. But before that, we can move all of these terms to the denominator as they all have a negative power. So negative 1 raised 3, 5 raised 3, x squared raised 3, a cubed raised 3. Negative 1 raised to an odd number is negative. 5 cubed is 125, x raised 6, and a raised 9. And we could also write this as negative 1 over 125, x raised 6, a raised 9. Either would work. Now, this is a good problem to demonstrate something. If you look inside the parentheses, every number has a positive exponent. And we are raising it to negative 3. And in the previous video, I mentioned that a raised, I shouldn't use a, I'll use a different letter. B raised negative m is simply 1 over b raised m. So I could write that as 1 over negative 5 x squared a cubed raised 3. Which would simply take us to that step directly. So it depends on how you use the rules and where you apply them. So the easier approach would be the one that I showed later, and recognizing that. Oh. So this might look silly, but if you have a number, a fraction, and you raise it to the power of negative 2, I'll tell you the answer and then I would explain how this works. It is simply equal to the reciprocal of the fraction raised positive 2. That's just how it is. And we'll see why. So I could write this as 5 raised negative 2 over 8 raised negative 2. So I have to move the numerator to the denominator, denominator to the numerator to get positive exponents. So I have 8 squared over 5 squared. The bases are different, but they have identical powers. So I can write it as 8 over 5 raised 2. Combine the two bases and raise it to the common power 2. So extending that concept right here in the previous problem, 5 over 8 became 8 over 5 and the exponent turned positive. So I'm going to do the same thing here. But before I do that, I would like to simplify the terms that are inside the root. Inside the power. So the numbers would be 5 over 10, x raised 7 over x cubed, those are the x terms, y raised 4 over y raised negative 2, And 5 over 10 is 1 over 2. The bases are identical for x, and since it is in division, you subtract the denominator power from the numerator. So 7 minus 3, I get 4. Same applies to y. 4 minus of minus 2 is 4 plus 2, so we get 6. So we have x raised 4, y raised 6 divided by 2 raised negative 3. I'm going to use the same logic that I used in the previous problem. 5 over 8 raised negative 2 is 8 over 5 raised positive 2. So x raised 4, y raised 6 over 2 raised negative 3 is the same as 2 over x raised 4, y raised 6 raised positive 3. And you can leave it as is, or you can apply the power to each term. So 2 cubed divided by x raised 4 raised 3, y raised 6 raised 3, which would give us 8 divided by x raised 12 and y raised 18. Okay, so we have a bunch of terms inside, and we have an outside exponent, which is negative. So what we have inside is negative 8 y cubed x a raised negative 2 raised negative 3. And I can take care of the negative exponents. So I have negative 8 y cubed x, move a raised negative 2 to the denominator. We have a raised positive 2, raise it to negative 3. So since we have a fraction raised to a negative exponent, we can simply flip the fraction and raise it to the positive exponent. Now we could apply the exponent to each term. So we have a squared raised 3, negative 1 raised 3, 8 raised 3, y cubed raised 3, x raised 3. Using one of the rules, a squared raised 3 would simply be a raised 6. Negative 1 cubed is simply negative 1. 8 cubed is 512. Y cubed raised 3 is y raised 9. And x cubed. So we would simply have a raised 6 over negative 512, y raised 9, x cubed, which is the same as saying minus a raised 6 over 512, x cubed, y raised 9. So here is a case where we have negative exponents, and then I have a negative exponent as the power. So what I'm going to do is convert whatever I have inside to positive exponents. So move the a raised negative 3 to the denominator, move the b raised negative 6 to the numerator. So we have b raised 6 over a raised 3 raised negative 4. Since we have a fraction raised to a negative exponent, I can flip the fraction, a cubed over b raised 6, and raise it to positive 4. And which we could write it as a cubed raised 4 divided by b raised 6 raised 4, which would give us a raised 12 divided by b raised 24. So here I'm going to use the same trick as the previous problem. The first step is to convert everything to positive exponents. So everything in the numerator has to come to the denominator, and the denominator a raised negative 3 has to move to the numerator so that we have positive exponents inside the parentheses. So a raised negative 3 moves to the numerator, it becomes a raised positive 3. X raised minus 2 moves to the denominator, becomes x squared. Y raised negative 2 moves to the denominator from the numerator, it becomes y squared raised negative 7. So we have a fraction raised to a negative exponent. So we simply flip the fraction. We can raise it to a positive exponent. So this is done by grouping. So I can just group it as 2 raised negative 3 over 5 raised negative 2. M raised negative 4 over m raised negative 5. N raised negative 5 over n. We'll flip every single one of them, so I could write the first one as 5 squared over 2 cubed. M raised negative 4 plus 5. N raised negative 5 negative 1. So 25 over 8 multiplied by 5 minus 4 is 1, so we have m. N raised negative 5 negative 1 is negative 6, which we can move to the denominator and have it as 25m over 8n raised 6. And that concludes exponents and scientific notation part 2.